Class, I hope you are doing well. Okay, so today we'll be looking at transforming exponential equations into simultaneous equations, but we'll be looking at a more difficult example. Okay, yes. So let's say you are given an exponential equation like this: 3 to the power x minus 2 to the power y plus 2 is equal to 49. And then 2 raised to the power y minus 3 raised to the power x minus 2 is equal to negative 1. Okay, so when you are given a question like this, you need to take your time. Okay, so first I can see a common exponent: 2 raised to the power y, 2 raised to the power y. Okay, here and here. I can also see a common exponent: 3 raised to the power x, then 3 raised to the power x. Okay, and because they are not the same, my goal will be to make them stand alone. Okay, so from the equation 1, I can say that 3 raised to the power x, this is our equation 1, this is our equation 2. 3 raised to the power x minus, we are going to use the laws of indices, 2 raised to the power y times 2 raised to the power 2. Okay, so we add, when multiply and add the index, we are going to get y plus 2 is equal to 49. And then 2 raised to the power y minus bracket 3 raised to the power x divided by 3 raised to the power 2 is equal to negative 1. Okay, so you realize that this is how it becomes. Okay, so I get 3 raised to the power x from the top equation minus 4 to bracket 2 raised to the power y is equal to 49. And then 2 raised to the power y minus 3 to the power x over 9 is equal to negative 1. Okay, so at this point that the 2 raised to the power y is standing alone without an index, the 3 raised to the power x is standing alone without an index, I can say that let say a be equal to 3 raised to the power x and b be equal to 2 raised to the power y. Okay, means that wherever I see 3 raised to the power x, I can put a. Okay, so I can say a minus 4b is equal to negative 49. And then this part is going to be, remember 2 raised to the power y is b. b minus a over 9 is equal to negative 1. Okay, so now I have two simultaneous equations. Let's remember that a is equal to 3 raised to the power x and now b is equal to 2 raised to the power y. Okay, so we have a minus 4b is equal to a minus 4b is equal to 49, and then b minus a over 9 is equal to negative 1. Okay, so this is equation 1, this is equation 2. When we multiply equation 2 by 9, we are going to get 9b minus a is equal to negative 9. Okay, equation 3. So when you solve this simultaneously, you are going to get b is equal to 8, and then a is equal to 81. Okay, but we said that a is equal to 3 raised to the power x, the same as 81. So we are going to use lots of indices. 3 raised to the power 4, since the bases are the same. Since the bases are the same, x is equal to 4. And then 2 raised to the power x, b is equal to 2 raised to the power x, which is equal to 8. 2 raised to the power x is equal to 2 raised to the power 3. 2 to the power y, 2 to the power y since the base are the same, y is equal to 3. Therefore, we get x equal to 4 and then y equal to 3. As simple as that. Okay, so you just have to isolate, like we have been doing all this while. Isolate the common exponent and then represent them with a variable. Then you solve. Okay, is that okay? So basically, that's what you have to do when you are converting exponential equations into simultaneous equations. Have a wonderful day.